Hi everyone, welcome back. We're getting ready to do the second half of section 5.5, where we're doing applications of exponential growth and decay models. We left off in this section was number 4. In this section, we are talking about using either growth or decay models so that we have to decide in order to start the problem whether we're using a growth model CE to the positive KT, or a decay model, CE to the minus KT. And whichever formula you choose depends on the context of the problem. So let's read number 4. The amount of goods and services that cost $200 in January 1996 cost $299.36 in 2005. Sometime later. Estimate the cost of the same goods and services in 2010. And then it says assume the cost is growing exponentially. Round your answer to the nearest cent. So we first have to decide what model they're asking us to use in this problem. Since it says the cost is growing exponentially, that means we should use a growth model here and not a decay model. So this is the formula that I've got to fill in all the data in. I need to know what C is, and I need to know what K is in order for me to use this model to answer a question. Now, in this particular problem, A represents a future cost of these goods. This is the cost is inflating and going up over time. So if A represents the future cost, C represents the initial cost of these goods and services, and K represents the growth rate of the cost. Now in this problem, if we read it again carefully, we'll see that they did not give me K, the growth rate. What they said was, well, they gave me data points. They said, first, these goods cost $200 in 1996, and then later on, in 2005, it cost $299.36. Based off of these two data points, they want me to predict what the cost will be in 2010. So instead of saying the growth rate is this, they gave me two data points. Well, I noticed the price was here on this day and here on this day. So they did not give me K. Right now, K is unknown. But in order for me to use this model and do something with it, I need to know K. Since it's asking me, ultimately, to estimate the cost of these goods later, what is it they're asking me to ultimately find? They're asking me to find a future value, A, for these goods. Find A. But if I'm going to punch out a future value of these goods, A, I need to know C, K, and T. So I need to figure out what K is in order to be able to answer the question and find A. So we kind of have to do some work off to the side. I first have to find K in order for this model to be useful to me in finding what A is. So in order to find K, we have to set up our model as best we know how so far. They said, we said C is the initial cost of these goods and services. How much were these goods and services starting out? They start out as $200 in 1996. So we should make a note here that our starting point here, T equals 0, represents 1996. And T equal 1 would be 97, T equal 2 is 98, etc. But our starting point is 1996 with T is 0. So under that assumption, our future cost is C, which this would be 200, the initial cost of these goods, E to the KT. So if C is the initial cost, C this time is here and find what K is so that I can answer the bigger question later. For this, I will use my second data point. These goods later on in 2005 were $299.36. So the future value A was 299.36 at a specific time. So that means at this particular data point, the value was 299.36. I have K is unknown, but we will know T. If T equals 0 is 1996, what T corresponds to 2005? So 2005 would be 9 years later. So we'd have at T equals 9 years, the future value A is 299.36. We will use this data point to solve for K algebraically. So let's solve for K the same way that we typically solve for T. Let's get E by itself by dividing both sides by 200. Divide both sides by the constant in front of the E. This would be 9K. I want to get rid of the E, so I take the natural log of both sides. The ln and the E cancel, leaving me with 9K equals ln 299.36 divided by 200. Divide both sides by 9, and you will have your K. You can punch this on your calculator. Now this K will be a decimal, and it represents the decimal value of the growth rate. So let's punch it out. ln 299.36 divided by 200 divided by 9. Now this is the value of K. Now you should never, ever, never, ever, ever, ever round this, because as soon as you round this in any way, you introduce a lot of error and your question will be wrong. So what you should do is keep all the digits of K when you're using this. So you can either write this down all the way to the end, or you can do what I do and you store this value in your calculator so you can recall. So there's a little button down here, a STO with an arrow, that represents store. So if you hit that button, store, this is what shows up. It's going to take this value you had here, your answer, and store it, and it wants you to know where you want to store it. So for this, I always select X, the variable there, so that it's storing that value of that decimal in for X. So you put X and then press enter. So now it thinks anytime I hit the number X, that's what X is equal. So if I hit the X key and press enter, it recognizes that my value of X is 0.044. Let's see, change. So this will help me out when I'm calculating things. K is that big old long decimal that now we know. So my model is about put together. I have A is C, which is 200, E to the K times T. But now I know what K is. It's that decimal that I've stored on my calculator. So now I can use this completed formula to answer the question. So let's read the question again. What's it asking? It says, estimate the cost of the same goods and services in 2010. So that means I'm going to have a particular T that I'm going to plug in to get a future value A. So it wants me to find A. So 2010, what value of T is that? So if I'm starting at 1996 and that's T equals 0, 2010 is 14 years later. So I have to find A at T equal 14. So let's plug that in here. 200 E to the K times 14. Remember, K, we knew what it was. We had it in our calculator. So let's punch this out. Get 200 E to the K, and this is where I put my X in, times 14. And I get 374.54. They want us to round to the nearest cent, so that means 2 decimal places. So my answer here is A is 374.55. Rounded 2 decimal places. That's $374.55. That's how much we estimate these goods and services will cost at that time. All right, let's continue on. I'm going to move to the next problem. It says, it is determined that the value of a price of machinery declines exponentially. So as soon as I see this term here, declines exponentially, that means that I know I'm using the decay model, A equals C e to the minus KT. A machine that was purchased 4 years ago for $70,000 is worth $34,000 today. What will be the value of the machine 4 years from now? So when we get to what it's asking me to find, what will be the value? They want me to find a future value A. So if we let A, according to this model, A represents the value of the machinery. If A is the value of the machine, C represents the initial value of the machine. And K represents the decay rate. This machine's worth is decaying at a certain rate per year. Now, in this problem, we will notice that just like last time, they did not tell me what the decay rate was. What they did tell me was a couple of data points. They said that when I purchased it, it was worth 70,000. So that would be your C. C is 70,000. That was its initial worth. And 4 years after that, so that is today, it's worth 34,000. So they didn't say it's declining at a rate of such and such percent per year. They gave me 2 data points. Oh, we noticed it was worth this much at this time, and then later it's worth that much. So we have to find K. All right. Let's put all our data in and find the value of K. So if I'm going to find, well, let's summarize. If I want to find a future value A, how much will it be worth 4 years from now? I'll need to know C, K, and T. That's why I need to know K, because they didn't tell me what it was. So I got to go work off to the side and find the value of K in order for me to be able to find A later. So for this, I'm going to kind of box this off to the side here, because I got to do some side work. Here's where we got to be careful. 4 years ago, this machine was worth 70,000. So if I were to put its initial worth, the 70,000, in for C, we have to recognize that that means that time t equals 0 represents that time where it was worth 70,000. That was 4 years ago. So 4 years ago represents t equals 0. So if 4 years ago is t equals 0, what represents today? That has to be when t is 4. So today is year 4 after we've started keeping track of this worth. Let's use this second data point here to help me solve for K. So at that particular point, the value A is 34,000. And T is today. That means T is 4. Let's solve for K here, just like we do solve for T. Divide both sides by 70,000. Take the ln of both sides to get rid of the e. And then divide both sides by -4 to get your K. Punch this out on your calculator, but again, don't round it. So that's the decimal I get for K. But instead of rounding it, what I'm going to do is either write down the whole entire thing there as your K so that you can use that in the next step, or you're going to do what I'm going to do and you're going to store it. You hit the store key down here, store as X, hit enter, and you just stored it. So now it thinks X is 0.18 and some change. I'll use that. But now I know what K is. It's that decimal. The whole thing, all of it. So now I can get to answering the question. It says, what will the value of the machine be 4 years from now? That means they want you to find A. So I know what C is. I know what K is now. What is T 4 years from now? I'll need to plug in a value for T. So if 4 years ago is T equals 0, and today is T equal 4, then 4 years from now is T equal 8. So I'm going to plug T equal 8 into this formula. A equals C e to the minus K. I have K. I know what K is. It's in my calculator. And I'll be plugging in 8 for T. Let's punch this out. We get A, and this is money, so we rounded 2 decimal places, is $16,514.29. That's how much my machine will be worth. Four years from now. All right, let's move on to our last one. It says the demand for oil in a particular country doubles every 4 years. How long will it take for demand to triple, round to the nearest hundredth of a year? So if we ignore the first sentence, when they ask us how long will it take, we should interpret that to mean they're wanting me to find a time, T. Find a time T for demand to triple. Now for this, we have to recognize something here. When they say the demand for a country doubles, it seems clear to me that I'm going to be using the exponential growth model. So I want to be CE to the positive KT because this demand for oil is getting bigger. So I should use the growth model. But they didn't actually, so if my objective ultimately is to find T in this formula, that means they have to tell me what K, C, and A are. But if we notice here, they didn't tell me what C was or A was. So if A represents the demand of oil, and C therefore would have to represent the initial demand of oil, they didn't tell you what the demand was. They didn't say right now we're consuming 20,000 barrels of oil. They didn't tell me exactly how much oil the demand was. But they did tell me that it doubles. And you should be careful there though, because doubles is not K. K represents a percentage. It represents a percent of growth. doubling is not a percent. So doubling is a ratio. Whatever I currently have, future value is twice that. So doubling is not a percentage of growth. Doubling is comparing a future value to my present value. In order for doubling to make sense, you have to know how much I currently have. So if I have a certain amount of oils I'm currently using, and you are using double that, you have to know what I'm using to be able to multiply it by 2. That's a ratio. Your value is double mine. It's comparing one to the other. So that's not actually a percentage of growth. That is a comparison of a ratio, you to me. So that is to say that K in this particular problem is not given again. They did not give me K, they didn't give me C, and they didn't give me A either. Now this is a pickle, because ultimately I wanted to find T. So I again have to come over off to the side and find K. We're going to have to do this off to the side because you can't answer any of these questions without knowing K. So if they don't give you K, you can assume that that should be your first mission, find K. So this is where we have to get a little bit clever about what's going on with A and C. We don't know what our initial consumption of oil was, so therefore we don't know what doubling that means. But we do know that whatever initial amount C was, that 4 years later, at t equal 4, the future value of oil, A, will be twice that. So it doubles every 4 years. So if C is an initial amount, whatever that is, the future value A is twice that at year 4. Let's use this to help me solve for K. A is 2 times C. C is an initial amount that I don't quite know. K is unknown, but I do know at this particular instance, at doubling, T is 4. So let's go about solving for K just like we have previously. What would you do? You divide both sides by C. C divided by C here cancels, and you've got 2 equals e to the 4K. This is no coincidence. This is your doubling. 2 equals e. Let's solve for K. The ln of 2 is ln e to the 4K. ln and e cancel. I've got 4K is equal to ln of 2. Solve for K by dividing by 4. And then you have your K. Now again, do not round K. You never want to round it. You want to keep every single digit of K. So either you write that whole decimal down right here for K, and use it in the next line, or you just make sure to use this whole decimal in your calculator. So I'm going to store this, store as X, so that I can recall it later. That's my K. I now know what it is. So at least I now have K, and I can use that to answer the question. Let's go back to what it's asking. It says, how long will it take for demand to triple? In other words, find T when demand triples. So in order to answer that question, I have to get clever again. If C is the initial quantity, then tripling means the future value of oil should be 3 times whatever C was. So let's use this and plug this in for A and C in my formula here to solve for the value of T. So you have A equals C e to the KT. Remember, K is known. And I'm going to plug 3C in for A and leave the C is unknown. And I'm trying to solve for T. T is the variable I'm solving for. I know what K is. It's in my calculator. Let's go through the motions of solving for T. You divide both sides by C. You get 3 equals E to the KT. And again, this is no coincidence here. That's your tripling. 3 equals E. Take the natural log of both sides. ln of 3 is equal to kt. Divide both sides by k. You will have t is ln of 3 divided by k. Now you know what k is in your calculator, right? We stored it. So punch this out. We have ln of 3 divided by k, and I stored this as my x. And we get this. Okay, so it says round to the nearest hundredth of a year. That's 2 decimal places. So I get t is equal to 6.34 years. $6.34. All right, and that is the end of this problem. It takes 6.34 years for demand to triple. Okay, we are done with this section. I will see you guys next time.